Welcome everybody, you're watching Mr. Fugu Data Science. Today we're doing something a little different. We're going to try to avoid duplicate entries using Postgres. We're not coding this out. I'm going to give you techniques and options for how to do this. Feel free to hit me up on my socials right here. Let's start. If you're performing an insert statement, you got two options. If you're dealing with an existing database or if you are not. You can insert batch files, numerous CSVs, or just a single line of code. But when you're dealing with duplicate entries, there are distinctions to consider. If we're dealing with an already existing database, we have a few tools that we can utilize. The first one being the distinct keyword. We could use group by clause. We could utilize inner join for two or more tables. We could use the overlap operator if we're dealing with arrays. If we have a database that we're creating and we would like to prevent the addition of duplicate entries, we have a few options. The first is called on conflict do nothing. We also have the unique constraint or index, and we have what are called triggers. Each of these has a nuance, and I want to kind of briefly go over what's going on between these because it's a little confusing. Let's consider this distinct real fast. You want to find a duplicate row based on one or more columns using a select statement. We have something also called distinct on. You have two versions and they're slightly different. The distinct on will help you find the first occurrence of a duplicate in your query. You can utilize this with multiple columns. The notation is different. Today we will not go into the notation. I just want to give you the techniques that you can use if you have a database or creating a database. This first technique is used if you already have a database. The distinct on, remember, this will help you find the first occurrence. If you're using the distinct, you're not necessarily getting the first occurrence, and it's difficult to know or track down what you're having when you're trying to filter your data. The ordering on distinct is not necessarily going to give you what you want. For instance, depending on how your data are set up, the distinct on will give you that first occurrence. There's something that you need to think about too. Here's something that's not always mentioned and it's a little debated. There's some speed considerations that people debate about using the distinct versus group by due to speed. I left a link here and it says that a temporary file is created during a group by, which can give you a speed decrease. I don't know the whole logistics of this on how it works on the back end. You could read up on that. Some people say that this is an issue if you're dealing with a large number of data. The read writes are creating a great deal of overhead. And while 5 or 10% speed reduction doesn't sound like much, depends if you have tens of millions or hundreds of millions of rows that you're trying to displace. That could be time consuming. The next thing we could talk about real quick is just a group by. These are just simple aggregate functions that are pretty flexible and it's supposed to be faster than a distinct, but I cannot verify this to be completely true. The overlap operator is something interesting which you can use for arrays, and what it does is basically says here's two arrays, we're going to see if they're comparable, they have similar elements inside them, if they're exactly the same or not, and it's going to output true or false, and then it'll give you the duplicate entry number. Like it'll give you a count. 1, 2, 3 entries are duplicated. Now we're going to do with preventing duplicate data before an entry into an existing database. So we got the on conflict, the unique constraint or index, and triggers. There's some performance things we need to consider real fast. So let's scroll down. When you're using on conflict, this is pretty interesting and useful because if we're creating a database, then it's a little bit different. And it depends on a few factors. When you're dealing with an insertion, you have pre-checks before that insertion. It's checking to see if this file exists. If it doesn't exist, then it inserts. Otherwise, it just deletes this file or entry number for this row and moves on. The reason this is different from other forms of inserts is the fact that it has this pre-check, and this pre-check, when it deletes it, it's not creating the overhead that you would get from other type of entries. For example, usually what happens when you're doing these checks, it'll create a new file, delete delete the old file, and you'll have what's called a dead tuple. This dead tuple occupies storage space and overhead. This is an issue that has to do with heap, and you end up running into something called bloat. So when you're scanning and updating old entries with new ones, this dead tuple, like I said, is creating storage space. And this can become an issue later down the road when you have billions of entries or even millions of entries. And there's tests that have been done. I have some research papers if you go on GitHub and look at some of my citations, like go through this and what happens. And it's kind of important. You want to try to minimize this because one thing that I would like to say that's really important, if you're uploading a lot of data, doing a batch insert, use the copy instead of doing a normal insert like you would do in row-wise operations. Bunch of files, for instance. Use that copy command for speed. It's going to help you out a lot. In order to remove the duplicates, like I was trying to say before, consider using a temp table. This is pretty good. And if you have any kind of constraints or anything like that, if you're worried about speed, what you can do is try to delete them. Indexes, any kind of things that are going to restrain you from your data because it has to do any type of scans. Things like this, like functions that you may have, other things you may want to disable them if you're inserting lots of data and then do everything after you have imported the data. That's just a quick tip for you. Let's talk about the unique index or the constraint. The constraint can be applied to one or more columns. Let me say this again. The constraint can be applied to one or more columns, but you cannot have repeating rows of information, and your null values are considered not equal, which is kind of odd, but you need to understand that. So your null values are considered to be differentiated. And there's a provision that you could use where if you want to make them all the same, you could do the nulls not distinct. In the case of creating a constraint, you also on the back end, you create a unique index. The reason you use index is, like for instance, if you had an index on some kind of column, it provides you the ability to do a fast lookup. When should you use this? For instance, if you have columns that are called quite often in queries, or if you need to use a where clause or some kind of join that you do often. But if you have to update these columns all the time, don't use the unique index or constraint. If you have some kind of small table, avoid it. If you have columns that you just don't use often, don't do it. And then this does create overhead when you're doing inserts and updates. That needs to be taken into consideration. Your unique index is creating a unique indexed column. Your unique constraint is ensuring that your duplicates are not created while making that unique index as well in the backend. The last thing that we're going to mention real quick are triggers. This is a hotly debated thing. A lot of people are going to say either yes, I use them, or no. I'm just going to say this. We need to look at a trigger as if you are creating a function that stores the information you want, and then it is doing something based on rules that you give it. Then you build the trigger based on some kind of syntax with what you want to achieve, and then you use your trigger to call the function that has all the operations you want. And there's steps of how you go through this procedure. Essentially, you have a callback operation that performs these events. If you're doing a bulk insert, try to avoid using these triggers because you're going to end up having overhead. It's going to slow you down. If you have a bunch of insertions through single lines, that's fine. You could even do that from what I've read into the hundreds of thousands of single line inserts, and it doesn't cause a problem. Your trigger is doing automatic tasks for you, such as if you're doing an insert, a deletion, or an update. And there's two options that you should consider. You either are doing a row-wise operation or you're basing it on a transaction where it doesn't matter on how many rows you're performing your tasks. So it could just group a bunch of rows. It could do everything based on just one single table, multiple tables, whatever you set it up as. When you're setting up the trigger, you could do it before something, after something, or in place of some kind of operation. A few examples that you can do with this are scheduling a task. You could handle some kind of errors. You could check for changes within your data. You could do auditing or logging. An example would be consider if you are auditing users and their actions for some kind of instance, or even if you're auditing personal information for users which will not be shown due to sensitivity or some kind of restriction. Let's say you're logging in and you're getting some kind of user information and the time they logged in and capturing this, or you're doing some kind of relative database related task which is private it. You could also do validation testing. A few good use cases are in these examples, and you're only going to see these if you get my GitHub. There are quite a few downfalls, so let's figure out what's going on. You got your good old performance slowdowns, which are going to affect your servers. If you have a high volume of data that you're using, this is not recommended. Debugging can be its own initial problem. Stored procedures within your trigger, try to avoid these. Be super leery if you're doing a cross-database or cross-server trigger because you have some speed concerns. Especially try to avoid this if you know that there's some maintenance that's coming up. If you have triggers firing more triggers, stay away. Be cautious if you got some recursive triggers because your debugging is going to be horrible and your performance could be a real nightmare. And try to reduce the number of write operations. That's really important. And when you're iterating and you're doing this row by row, your read or your comparison is drastically reduced, affecting your performance, such as if you're using a while statement or cursors. There's some differences if you're using Postgres and MySQL for when you're setting these up, because Postgres will let you truncate triggers. You have the option of trigger functions, which are needed to call the actual trigger, and then you have normal operations like create a trigger, drop, alter, disable, enable. The few takeaways I would say are this. The person who's handling this database needs some privileges or permissions to work with triggers or to execute them. If you want to see what's going on in the database, such as what are all the triggers we have, you could do the pg_catalog command. If you're creating multiple triggers that fire on the same object, you need to understand that they're going to run in alphabetical order. So this may be an issue for you, but it's something you need to take note of. Lastly, here are the few steps that we're going to look at. When you're actually setting up this trigger, you want to create this trigger, right? But you're going to set up a function first that has no parameters. You then are going to call the trigger where you're creating some kind of trigger name, and you decide, do I want this event to be before or after something, such as an update, an insert, a delete, or a truncate. And then you need to call that table name. You're going to use the on keyword, and then you're going to do a for each row, or this is a row by row reference, or if you're doing a statement, you're going to say for each statement. You're going to then execute procedure. This is what you would write, and then you have to put your trigger name in the end. Now that's the end of this video, but feel free to hit me up on my socials right here. But please like, share, and subscribe, and if you subscribe, turn on that notification bell. This video will be showing examples for each one of the 6 or 7 options that you have between either an existing database or if you're creating one to deal with duplicate values, just due to time's sake. So feel free to stay tuned. I would consider going to my GitHub and pulling all of this stuff. But if you could help support this channel, it'd be greatly appreciated. Buy me a coffee, super thanks channel memberships. Thank you to all the people who've helped me over time with suggestions and comments. I greatly appreciate it. I'll see you in the next video. Bye.